Why did you want to be an astronaut?
You know, it's funny they asked me that in the interview, and I didn't have a good answer for them either. It's something that caught a hold of me when I was in middle school, believe it or not, and I've always liked science and technology and math. It's always been fun to learn how the world works and to see new things and learn new things, and there was something about flying in space that just grabbed a hold of me and didn't let go. So here I am. A little bit of luck, a little bit of hard work, here I am.
Well, I'm going to find out how you got there. So let's start with your hometown. Tell me what it was like to grow up in your hometown.
Well, I grew up in Belleville, Illinois. It's near St. Louis, but on the Illinois side of the river. Medium-sized town. A lot of family living in the area. It was really quite a nice place to grow up. Very solid, well-grounded community. Lots of very nice people, and I enjoyed it. You know, we had St. Louis nearby if we wanted to do big city stuff, but we were yet a smaller town, so we didn't have a lot of the big city issues, and it was a good place to grow up.
Did you get a chance to see it from orbit?
I did. I took some pictures of the area, of course, and showed them to my family, found the street my mom lives on, sent her that.
Big cities are easier to see than small towns, and you're talking about picking out a street?
Yeah, but I had 4.5 months to practice.
How do you feel like the people there and that place helped make you the person that you are?
Well, as I said, it's the Midwest. We're very well grounded in the Midwest. People are friendly. They value, hard work and discipline, and they help each other. It's just a really nice community. I really value the fact that I got to grow up in such a great place.
Well, tell me about how you go from Belleville into college and into your professional career. What's the path that led you from there to here?
Well, following my interests really is probably the best way to describe the path. I enjoyed studying physics when I was an undergraduate. I didn't know much about engineering until I got to college because there wasn't really any engineers in my immediate vicinity. I got to college, discovered engineering, thought that was kind of interesting, so I dabbled a little bit in electrical engineering and ended up doing a master's in that after I started working at McDonnell Douglas for about 4.5 years. While I was at McDonnell Douglas, my job involved working with airplane design and materials specifically, and how they function, interact with electromagnetic fields. And so I got interested in materials, like, oh, that's kind of interesting. I didn't know that existed. So then I wandered off to Georgia Tech and did my PhD in materials. At that point, I thought, okay, I think my resume looks all right, so I can apply to NASA and see what happened. And what happened was I got selected, and here I am.
Was the idea of applying to NASA always there from your undergraduate days on?
Oh yeah, it was always in the back of my mind. I just didn't feel ready to apply until I was nearing the completion of my PhD.
You got into a job where there's a big part of it, the flying in space part of it, that has got dangers that most PhDs don't have to encounter. Sandy, what is it that you think we get as a result of flying people in space that makes it worth that risk?
Well, a comment about the danger part first. My brother is a police officer. On a daily basis, he's probably in more danger than I am because I don't fly in space every day. I fly in space once every 5 years. So I have like spikes of danger, and he's got sort of low-level danger, so I let people decide which one's actually truly, in total, the more dangerous job. But aside from that, yes, flying in space is definitely risky, but we learn a lot from being in space. I mean, even just about how the human body changes, and these insights can help us fuel creative ideas on how to solve problems here on the Earth. You know, for example, if we can figure out what's going on with the bone density, and for example, even if you don't lose bone density, your bone regrows, but the structure's a little different. So what does that mean? Could that be harmful or beneficial? And if it is beneficial, could you duplicate that down here and help people? You know, and we get a lot of these serendipitous discoveries. You know, we've done some cancer cell research up there and found a little bit new and unusual things about how cancer cells grow. We're finding interesting things about the virulency of some diseases. We're finding interesting things about how materials operate. We're finding interesting things about just fluid dynamics, and all these little pieces of information can be used here on the ground to create things that can help people, or technology that can do new things. And it's, you know, you just get a lot of information like this, and we don't even know what we don't know, and by going there we can learn these things.
You're one of 4 crew members on the final flight of Space Shuttle Atlantis. Sandy, give me a summary of the work that's planned for mission STS-135 and what your jobs are going to be on this flight.
Well, it's a very busy mission. Our prime job, of course, is to take tons of logistics up to space station and get it up there while we still have the huge cargo carrying capacity of the shuttle available. In addition, we're tasked with bringing down the pump module, which failed late last year, because it failed a little bit earlier than expected, and we need to dissect it and learn from what happened and how to improve our engineering designs. So those are the primary mission parameters that we're working with.
Something new about this flight is that there are only 4 shuttle crew members. Why is that?
Yeah, it's going to be a challenging mission with only 4 of us, but really the driver for that is the fact that our rescue scenario is a little bit different than normal. You know, ever since Columbia, we've been mandated to have a shuttle on the pad ready to launch in case the crew has an issue with the orbiter and then they need to be rescued. Because we are the last orbiter, there's not an orbiter there waiting for us. So our rescue scenario involves the Soyuz capsules, which we're flying to station via the Russians, and on the Soyuz capsules only 1 person can come down at a time. So if the crew of 4, that then takes a year to get everybody down, and that was deemed to be enough. You know, you don't want to have 6 or 7 people up there. You know, take close to 2 years to get everybody down.
Why would it take a year to get the 4 of you home that way?
Well, as I mentioned, the Soyuz is it's a 3-seat vehicle, and of course you're still having crew rotations occurring on station, and so they'll fly up with an empty right seat. So that means 1 person will be able to return with each Soyuz, and so for 4 of us, when the Soyuz is launching every 3 months or returning every 3 months, that's a year.
And that's on the assumption that the Soyuz flies at the same regularity.
Yeah, and I think that's a pretty solid assumption.
How comfortable are you with the idea of flying on a Soyuz and of maybe getting a few extra months in space?
Well, actually, for me, it's not really a problem because, as you know, I've lived there for 4.5 months already, and my stay would be about 9 months, so it would be double the time that I've spent there already, and I'm already trained on the Soyuz since it was part of my space station training process. So I feel pretty comfortable with it, and I'm very familiar with the station, and it's fun living on the space station. It wouldn't be a problem.
Well, let's talk about that training. You have been to the station for months. Each of your shuttle crewmates has been to the space station before. How's that experience help you folks get ready for this flight?
Well, clearly, having been to the station before, whether it's for a short duration or having lived there, is very helpful in a training flow like this, because we're already familiar with what the station does, how it operates. We've been there, we understand how things work on board, and we can very easily fall into the efficiency of operations that we need to have once we get there, and with 4 people in a short period of time to transfer all of these things that we're transferring.
What are you looking forward to seeing when you get back to the station?
Well, it's only been 2 years since I've come home, and since I've been gone, they've delivered 3 more modules in the cupola, so the station has grown even bigger, and I'm looking forward to seeing what it looks like now. I mean, it was already huge while I was there, and I've been told the views out the cupola are stupendous, so I'm really looking forward to spending some time in there and seeing the whole horizon at one time.
The station's bigger, the crew is bigger too. It'd be kind of a different experience.
Definitely. We were the last 3-person crew when I was on board 2 years ago. Now we have 6 people, and with us there'll be 10 total, which doesn't match the highest amount we've ever had, but it'll be crowded, but I don't think it'll be too crowded, because, as I said, the station is really huge.
Well, on this flight, you're carrying a shuttle full of supplies for the International Space Station. Give us a sense of what kind of cargo you and your crewmates are bringing to orbit.
Well, we're taking a year's worth of food, for one thing.
1 year's?
1 year's worth of food. We're taking about 2,000 pounds of science equipment. We're taking hygiene items. We're taking clothing. We're taking thousands of pounds of spare parts for the different systems, life support system, the electrical system, the computer system, and so forth. These are the big things that we're taking, because we're trying to supply the station for a whole year, and that hedges our bets against when the commercial follow-on cargo contracts will be available and up and running.
I'm trying to envision all of that packed into the crew compartment of the space shuttle.
Well, it's not packed into the crew compartment. We have a multi-purpose mission logistics module in the back end, and so that, as you know, that comes out of the payload bay as a big cylinder, comes out of the payload bay with the robot arm, it gets attached to the station, and we open up the hatch, and that's where all of the transfer really will take place. The mid-deck has several thousand pounds, but the MPLM has several tens of thousands of pounds.
And nothing to sneeze at what you can put in the mid-deck.
No, we can get a lot into the mid-deck these days, and especially since we don't have anybody sitting on the mid-deck, instead of where the seats are, they've put stowage bags. So we have 3 extra stowage bags on the mid-deck than any other mission.
MPLMs, as you mentioned, have usually been attached to a place on the station, on the Unity module, that's filled right now with a permanent attachment. So where's the MPLM going to go this time?
Actually, for the last few missions, the MPLM has gone nadir on Node 2. So we're not any different than, and like for example, when I flew on 126, we were an MPLM module mission as well, and we attached it to Node 2 nadir, which is where ours is going to go. The permanent MPLM, which you're referring to, is on Node 1 nadir, and so it's not really going to be an issue. We'll take stuff out of the Node 2 nadir spot, translate down the lab, and most of the stowage and transfer that we're doing will be in the permanent MPLM that's on board.
In terms of the robotic operations to install it then, does the existence of this other MPLM on the bottom of Unity cause any change to the way the arm has to maneuver to install the new one?
No, not really. They may have to base it in a different location, but I'm pretty sure it can still be on where it is now is pretty much where we had it from 126, so that's not really a new element. It is something, however, when we're flying procedures, robotic procedures in support of EVA, we have another blivet that we have to watch out for. So.
Now, there's also one spacewalk in the plan for this mission on Flight Day 5, but unlike previous shuttle flights, there are station crew members who are going to be going outside to do the EVA. What's the reason for that change in the assignment?
Of course, that's another consequence of having a 4-person crew. Mike and Ron are very experienced crew members. They're already on station. They can train for the EVA before they launch. It'd be difficult for us as a 4-person crew to train an EVA crew in addition to everything else that we're doing, because we're having to cross-train a lot. Normally if you have a crew of 6 or 7, you can send the EVA sub-team off, and they can do some training while the flight deck team is doing some other training, and you can work in parallel that way. Well, we can't do that because there's only 4 of us. We all have to be at every single training event that they have, basically. And so by offloading the actual EVA to the station guys, that allows our turning flow to be reasonable. Now, we're all supporting the EVA. For example, Rex is operating as the IV. Fergie's the airlock IV. He'll be suiting up the guys to get ready to take them out, and Doug and I will be supporting doing the robotics. So we're involved in the EVA, but the actual EVA operation will be run by the station guys.
Okay, well, tell us what's on the agenda. What are Mike and Ron going to do outside, and what kind of arm support is required?
Well, as I mentioned, one of the prime mission goals is to bring back the pump module, which failed last year. And so the mission 133 mission placed the pump module on the storage platform just outside the airlock, and we're going to go basically pick it up and put it in the payload bay. And it's very huge, and so you need the robot arm to move it from place to place. So Ron will get on the arm, and then they'll remove the pump module, and we'll carry him over to the payload bay, and then Mike and Ron will attach it. So while we're in the payload bay attaching the pump module to the logistics carrier, we'll retrieve this experiment for the special purpose dexterous manipulator that will allow the robotics community to show the ability to do remote refueling and other dexterous tasks that might be involved in servicing satellites. So this payload will go out on the truss, and then they'll bring the SPDM over, and they'll practice all these different very delicate operations as a technology demonstration and operational concept development, so that perhaps someday you could send robots to service satellites.
And those are activities that are going to happen later.
Yes.
But your job is to get it out there.
Yeah, we're delivering the task board so that they can go do their development later on.
And that pretty much the EVA tasks for your mission.
Those are the 2 prime ones. There's several reserve tasks that the program is looking at based on the time that it takes to do these 2 tasks and where we are in transfer, because the primary driver for our mission schedule is getting things transferred from the MPLM into the station and then bringing things home and repack, to pack to bring home in the MPLM. And everything revolves around making sure we have enough crew time to get the transfer done. So if it's determined that we have enough crew time and we're doing well with transfer, then Doug and I can support robotically a little bit longer in the EVA time frame, and there's a few other tasks that can be attacked at that point. So there's still a little bit of flux there.
And the scheduling is that fine, that tight?
This mission, the scheduling is that tight. They're looking at 15-minute windows, half-an-hour windows, and having debates at that level to figure out how to get enough transfer time on the books so they feel confident that we'll be able to move everything from MPLM to station and then from station back to MPLM in the mid-deck.
Well, as you say, the transfer work is the top priority, and it takes up most of the time. It's almost like you're packing up and moving two houses back and forth within the body of the space station. Can you give me a sense of what is involved in not just moving things, but knowing where things are all the time and coordinating what's going in which direction?
That, of course, is the tricky part, and I am the load master for this flight, so I'm intimately involved in that, and there's a great team working on it. We're coming up with a very efficient plan for how to move things out of the MPLM very efficiently and then move things back, because there's a lot of constraints and dependencies. This MPLM is all stowage. There's no racks that get transferred. In the past, we've been able to transfer whole racks of equipment, and so we have to rotate some racks. There are some racks that block access to other racks in the stowage in there, and so there's a very efficient plan that has to be thought of, so you're not constantly having to backtrack and get into things that you've already buckled down. As well, we've got bags on the station that are waiting to come back in, and getting them in efficiently, and then dealing with some of the remnant foam that we inevitably send up to station. That'll keep us busy, but because the team on the ground is so solid, I feel that we'll have a really good plan to operate on.
The foam you're talking about, that's packing material?
Yes, we are very enthusiastic in our use of packing material here at NASA, and the goal is to not leave a lot of that excess up on station, because it's just trash that has to be gotten rid of later. And so one of my personal goals for this mission is to minimize the amount of foam that we leave on the station.
The task you described seems like it almost has to be scripted out, one bag at a time, in order to make it work.
Well, you don't have to go one bag at a time, but you do need to think about how the racks interfere with each other. And so you have to think maybe at rack level or even half a rack level. But again, the team that is planning this is very experienced, they're very competent. I have huge amounts of faith in them, and I think we'll have a really good going-in plan. Of course, you always have to alter it as things happen, but if you have a really solid going-in plan, 98% of getting anything done is the planning, and we're going to have a great plan.
Is a general philosophy to first empty the MPLM and then bring the returning stuff in to pack it up?
That is a philosophy, but that's not necessarily the most efficient way to do it. Again, it's because how you have to access the rack. So we're going to actually be emptying and filling all at the same time. For example, there's some places that are blocked, these support structures that we have to fold out of the way to get to some blocked access. So when we take the resupply items that need to go to station out of that spot while we have that structure out of the way, we're going to put the return items that are coming home in at that moment, so we don't have to move the structure out of the way more than once. So it's better as you plan to think about these kinds of things so you can do the swap and not have to, like I said, go backwards.
It's a giant puzzle?
It is. It's a three-dimensional puzzle. It's a giant three-dimensional puzzle, so we'll be busy.
When the joint timeline on the station is over, you and your shuttle crewmates are going to mark a milestone with the last undocking of a shuttle from the International Space Station. Is there anything special on the plan for that undocking operation itself as Atlantis finishes the shuttle's mission at the station?
Well, we're hoping, we've had some discussions with the imagery folks, and that we do a lot of photo documentation of the station as we do the fly around as we leave, so that they can keep an eye on how the station is doing, if there's micrometeorite hits or how the solar rays, the radiators, things like this. And one of the things that we've really not been able to do, all of the fly arounds are along the long axis of the station, where this is forward, this is aft, and the truss is this way. We're going to, this program, both the shuttle and the station program, are working on actually rotating the shuttle either 45 or the station 45 or 90 degrees, and we'll do a fly around in an opposite manner, and we're able to photo document the station from a different aspect and get some very valuable information for the imagery guys. So that will be very interesting because we'll have different, very different photos from our fly around than any other mission before us, and we're looking forward to trying to do that.
Yeah, a view that very few of us have ever seen. I was thinking about, is there anything special that you're going to be keeping your eyes open for during that last fly around and that final separation?
Well, I'm lucky enough to be the photo person during the docking and undocking time frame, and I'm very much looking forward to just having some nice time at the window and just taking tons of photos of the station, hopefully getting, first of all, good documentation for the engineering folks who need the photos to study how the station's doing, and second, try and get some of those pretty shots that NASA chooses to use every now and then. We'll see. It'll be a really unique view, though.
We need more beauty shots.
Yeah, the station's a beautiful thing.
When you were assigned to this flight, it was supposed to be a rescue mission for what was the last shuttle mission, and it was going to fly in the summer of 2010. The plans for that have all changed. What was your reaction when you came to realize, I'm flying on the last space shuttle mission?
Well, first of all, I have to say being assigned to a shuttle mission again of any kind was a big surprise for me. After doing my long duration mission, I had assumed I was now in the long duration pool of folks. And I was actually up working in Washington, D.C. when I got the phone call to come back to Houston and train for this. So I was surprised just in general to be assigned. And of course, we've always known that the rescue mission could potentially turn into a mission. And so that wasn't, that's always been a 50-50 proposition. So the big surprise for me was just getting assigned to a shuttle mission at all.
Is there a special sense of responsibility or honor of being part of the last crew?
Well, I certainly feel honored to be part of the last crew. I think, and the thing I think that I feel the most honored about is it requires a special skill set to operate with the crew for, and I'm very flattered that it's felt that I have that skill set that is needed to do that. I'm very, very flattered by that.
The end of the shuttle program means a lot of change at NASA, and that includes layoffs and shutting down some historical facilities. What's your feeling about the decision that was made to stop flying the shuttles?
Well, as you know, the decision was made to stop flying the shuttle back after Columbia, when the Columbia Commission reported that the shuttles have clearly been flying for decades. They weren't designed to fly for decades. So in 2010, NASA has to make a decision whether to overhaul the shuttles and give them a really good shakedown to make sure they're going to continue to be able to fly safely, or cancel the program and move on. So that decision was made a long time ago. So I think, looking back, that was probably the right choice to make. The unfortunate thing is how the transition is actually occurring. That basically, from that point when that decision was made that we're going to, in 2010, cancel the shuttles, that put NASA into a time of transition. Of course, the time of transition could last for a decade. And we've had a lot of turmoil during this time as different agendas are brought forward for what NASA should be doing. And it's caused, because of the way it's all played out, we're in a situation now where unfortunately we're losing a lot of important skill sets. You mentioned the layoffs. As a matter of fact, we had our CEIT just last week, and the people who were there helping us get through the CEIT were getting laid off the next day. It's really heart-wrenching, when you come down to the individual level. So during this time of transition, we're finding ourselves not able to enact the next plan in time to save certain skill sets, and that I think is the unfortunate thing. I think we will get a plan. I think it'll be a good plan if you listen to the agendas of different entities that are arguing over the national space policy and trying to formulate it. There's general agreement that we should go beyond low Earth orbit, and that of course reinforces the idea that the shuttle's time has come because it's a vehicle that was designed for low Earth orbit. And so we will get our plan, but in the meantime, it's been a little unsettling in the transition.
Every mission has to come up with a patch, and yours we see on your shirt. Talk about some of the elements that are there, because you see parts of the NASA emblem, but also the last letter of the Greek alphabet.
Well, of course, Omega came to mind immediately as as it is the last letter of the Greek alphabet, and we are the last shuttle mission. So we wanted to sort of highlight that this was the end of the shuttle program. And of course, it's not just something that affects the shuttle program, but it affects all of NASA. So we felt like having part of the NASA symbol in our patch was appropriate as well.
What do you think are the most significant moments in the space shuttle history?
Oh my, you know, there are so many. We can talk about the launch of the Hubble, we can talk about the repair of the Hubble, we can talk about the space station program and what it's been able to do there. We can talk about some of the great science missions, you know, the radar mapping missions, and there's so much that the shuttle's been able to accomplish. But I think really some of the greatest moments in our history as a shuttle program has come after our disasters, because you see there what the people of our space industry are really made of. You know, what the space industry is really made of. We have this horrible event, we lose a vehicle, we lose crew, and everybody pulls together and just tackles the problem. And I was involved in some of the Columbia work, and I was just so impressed and so amazed. You have this extremely complex problem. We broke it down into little pieces. Everybody worked so hard with such fierce determination to solve it. Brought all the pieces back together, found the solution, and continued to fly. And I can't think of any other industry on this planet that can do that. And it says a lot about the people that work in the space program. It says a lot about just the shuttle program in general.
And doing it out in public in front of everybody.
Definitely. And doing it with a lot of an emotional context to it, because, you know, we lost people there, and that's just hard.
What do you think about Atlantis, this particular orbiter? What will it be remembered for?
Oh gosh, you know, I have to tell you, at least in my heart, Atlantis was the first one that I flew on for STS-112, and that'll be my last mission as well. So it has a hold a special place in my heart. But I think, you know, all of the orbiters each have their own personality, have their own sort of following, and so, you know, for the people who have worked on Atlantis for so long, I think it's special for them that it will be the last mission.
For the people who are not as close to it, they all look alike. What makes Atlantis different? What's peculiar about it?
Well, I mean, technically speaking, Atlantis does not have a modification that allows it to pull power from the space station, so it's a little bit different there. But I know it's hard to put your finger on it. You know, they all have their own little quirks and their own little personalities, and it's just hard to describe.
How will the work of the shuttle program, the whole program, be remembered?
I think it'll be remembered as one of the most unique programs in the history of spaceflight. You know, if you look at what the shuttle can do, it's a very versatile vehicle. We mentioned already the science missions that it had. We mentioned already the repair, deploy and capture of satellites. We mentioned the space station. And if you look at how the shuttle program has evolved, it wasn't clear when the shuttle was first built what it was going to be doing in particular for all these different missions. It sort of grew into being able to carry out all these missions because of the versatility that was inherent in the design of the vehicle, and because of the dedication and the creativity of the people who worked on the program for so long. So I think when you look back at the shuttle program, you're going to see a vehicle that was adaptable to the fullest extent over the 30-year life in ways that the original designers maybe have had vague ideas about, but certainly no concept of the wide variety of tasks that the vehicle was going to be able to perform. In addition, it'll be unique, I think, in history for a very long time in its ability to return cargo from space. And that's been key for a lot of science that we've been able to do. Because it's not only important to do the experiments on orbit, but it's also important to be able to bring your samples back and get your data back and things like that. And the orbiter has been very unique in that sense, in addition to things like bringing the pump module back and other large pieces of equipment on the space station that have failed over the years. We bring those back on the orbiter, and we can learn from them. And it's been able to do that for us as well. So I think there's a lot of key things and capabilities and qualities that the orbiter has had, that the shuttle program has used it for, that will be celebrated for a very long time.
Lately, excuse me, lately we've been using it to build a space station. What kind of space station might we have today if we didn't have the space shuttle to use to build it?
A much smaller and much less capable one. If you look at the space station now, you will see this huge monster building in space. You will see science racks and experiment facilities that are on board because the shuttle could take them there. Without that, the station would be much less capable and have a lot less going on than it does now.
After STS-135, it's going to be up to spaceships from other nations and perhaps private industry to get crews and cargo to orbit for the foreseeable future anyway. As an American astronaut, how do you feel about the future for the International Space Station?
Oh, the future is very strong for the International Space Station. I think, it's an entity that we're flying with a lot of other countries. There's a lot of interest in it. There's a lot of useful things we can do on the space station. We know for sure it's going to 2020. It could even go farther, who knows. So I think there's still a lot of capability in the space station, and there will be a lot of good science to come out of the work that we're doing on the space station.
Do you remember where you were when STS-1 took off and what you thought about that flight?
Gosh, I was in high school. I was in high school, and it was just pretty spectacular to see something launching with people in it, even on TV. It's like, wow, look at that. That's really cool. It looks like an airplane, but it's launching like a rocket. Wow. It was really different.
What's your favorite memory out of the space shuttle program?
Well, I have to say my favorite memory is very personal. I was on Atlantis when we opened the payload bay doors right after we got to orbit. I was on the flight deck working in the aft flight deck area, opening the payload bay doors. And as the payload bay doors opened, I looked down at the Earth for the first time and saw the horizon. And that was very special.
Destinations have changed a lot in the 30 years since STS-1 kicked off this era. Where do you think we're going to go in the next era of space exploration?
As you know, that's a very hotly contested debate going on right now, with a camp stating that we need to go to the moon, another camp stating that we should go to asteroid, another camp stating we should skip all that and go directly to Mars. Those are the three that I hear the most about. I think, as I mentioned earlier, everyone's agreed we need to get out of low Earth orbit, and the next step is to go forward, and that's a good thing. I think we'll find that it'll be almost irresistible to use the moon as a test bed of some sort, and then the big debate would be how long. But it's in our backyard, and it makes sense to do some technology testing there and some technology development there. And it's quite possible that the destination that we will end up going to is one we don't even know yet, because as you know, we're still exploring. There's other places of interest in our solar system, and who knows? I think anywhere we go is good because it's broadening the frontier, it's pushing technology, and it's getting us further and further out into the solar system.
Who knows what we might find as someplace we want to look at.
We still have all these telescopes up there, and they're still telling us a lot about the universe and the solar system, so we'll see. It's interesting, though, the technology that would need to do any of these destinations is pretty much the same. So we can move forward and get ourselves ready to make the jump while we're still having this debate about what the final destination should be. And final sort of relative term, isn't it? Because once we get to the next destination, then we'll have one after that. So I think the next destination is probably a more appropriate term.